Hello everyone, my name is Nada and I'm with my friend Jiyu and Rory Norn. We are all from Physics Honor Class Period C, and today we'll be presenting about our physics project in the topic of projectile motion. So let's get started. Okay, so before we show you guys the calculation, I'll be telling our apparatuses or the material we use to conduct this experiment. So first of all, we use the same materials for all the three trials of the experiment for the accuracy. So we have future board and books for the slide, and we used a ball and notebooks for the ball's track, so the ball doesn't roll away. And then we also use a ruler to measure the height of the slide.
During the three trials, the only variable that changes is the height of the slope, which also makes a wider angle.
Okay, so now we'll be showing the coloration of height, range, and angle of the projectile motion. First, we'll be starting with our calculations. And now it's our first trial. To find the acceleration of the first trial of the projectile, firstly, the projectile of the height is 2.5 centimeter, 15 degree, and 2 seconds. To find the acceleration, we're going to use gravitational force, which is 9.8, by multiplying sine 15 degree, which is the angle of the projectile. Thus, the result will be 2.5 centimeter per second square. Next, Nara will be explaining about the velocity of the projectile.
Okay, so to find the velocity of the projectile, we'll be using the kinetic formula, which is velocity square equals to initial velocity square plus with 2 times acceleration times with distance. So as you can see here, we're missing one variable, which is distance, so we need to calculate our distance first. So to calculate the distance, we'll be using the formula sine equals to opposite over hypotenuse, which in this case is height over distance, but we want to know the distance, so we'll be changing the formula to distance equals to height divided by sine theta. So the distance after substitution, it will be 2.5, or the height, divided by sine 15 degrees. Hence, the answer is 9.66 centimeter for the distance. And then after knowing the distance, we'll be substituting it into the kinetic formula. But as you can see here, the ball is released at 0 meter per second, so we can cut out the variable of initial velocity. And we'll be left with v equals to square root 2 times with acceleration times with distance. And after substitution, our answer is 6.95 centimeter per second, but we want to change it into SI unit of meter. So our final answer will be 0.0695 meter per second for our velocity. Next, Rory Norn will be explaining the next step.
To find the range, multiply the velocity on the x-axis with the time that we measured. Therefore, we'll substitute 0.0695 multiplied by cos 15 and times that by 2. And that will give us 0.134 meters.
And that is all for our first trial. Next, we'll be moving on to the second trial.
For the second projectile, the height is 5.5 centimeter, 20 degree, and 3 seconds. We will use the same method as the first trial, but the number of height, degree, and time is different. And by replacing those numbers in the equation, the answer will be 3.4 centimeter per second square.
So similar to the acceleration, we'll be using the same method again, but due to the change of variables, in this case is the height and the angle. Our distance has increased from 9.66 centimeter to 16.08 centimeter. And because the distance have increased, our velocity have also increased to 10.46 centimeter per second, or 0.1046 meter per second as well.
So for the range, because the velocity have increased, the range will also increase. So it will be 0.589 meters.
Lastly, the third trial height is 1.5 centimeter, 10 degree, and 2 seconds. Same as the previous trial, we will replace the number in the equation and the answer will be 1.7 centimeter per second square.
For the velocity, we have also changed the variables as well, but this time it is less than the second trial. So our distance is lesser than the second trial, which is 8.64 centimeter, and hence our velocity is 5.42 centimeter per second or 0.0542 meter per second.
So for the range, this time the velocity have decreased. So it'll be 0.107 meters.
Okay, so to conclude from our experiment, we can conclude that the correlation between the height and the angle and range is that if the height increases, the angles increases, and if the height and the angle increases, the range also increases as well. Okay, that is all for this video, and it is the end of our experiment. We hope that you guys learned many things as well. Goodbye.